الرحيم وأصلي وسلم على سيد المرسلين نبينا محمد أفضل الصلاة والتسليم. طبعا موضوع الجلسة هذه اللي هو جذب أو الاستثمار الجاذب attractive investment. Investment, I believe, in solid waste, the component of the solid waste. The general belief that solid waste is like treasure, which is correct, but different people have different thought about it, and there are different school of thoughts about this one. Obviously, is not profitable. It's the investment needs subsidies from concerned authorities and agency in order to promote recycling and reuse of the some of the solid waste components. I believe we do need to work on this kind of recycling in order to make it a real investment that will encourage businessmen and other investors to participate in this issue. This session, we are already late now by almost 15 minutes almost. I will start with the keynote speaker, Professor Horashan Hitrashashi. Sorry because it's a bit difficult for me. Professor Hiroshan is a civil engineer professor from the United States. He's currently serving as head of the units called Waste Management at the United Nations University, which is an integral part of the United Nations itself. Before joining the United Nations University, he was a professor and director of civil engineering graduates program at Lawrence Technology University in Michigan. Most of his works cover multiple topics, including sustainability, circular economy, nexus thinking in environmental resources management, waste management, and geotechnical engineering. Cover a broad spectrum of engineering and in particular environmental. So please, Doctor.
Thank you.
You have almost 20 minutes. 20 minutes.
All right, thank you very much. Good afternoon. Can you all hear me okay? All right. I wanted to see a full house, but it's half empty. Let's start. Maybe the others will join. You saw my name. I'm not going to say, okay, well, too fast. Hiroshan Hetiarachi. It's not an easy name to say. I understand. The essence of my topic is actually circular economy. The conference themes are very much related to circular economy because it actually sits in the right middle. We're talking about waste management, sustainable waste management, in our way to secure the sustainability of natural resources. We need a method to make it happen. I believe circular economy concept can help us. Now, what do you see in this picture? I'm sure you can, I'm not really asking like in a classroom, but I know the typical answers. You see a lot of metal, you see some old junk. Definitely they are old, not in use. But do you see beyond? What I see is tons of metal stuck in one place for more than 30, 40, 50 years, and we don't know how to use it. The material value is in one place, we don't know how to utilize it. So this is about metal. Well, I mean, it's about the mineral resources, right? Okay, I'm sorry, I'm still getting used to this. The second picture, after the metal example, what do you see in this one? Food waste. Yeah, it's a completely different example from metal, but well, I see so many other things in it too. I see water. I mean, how much water have we spent to produce this food? I also see energy because we have spent a lot of energy to produce water to irrigate this crop. And I also see how much we can benefit from this waste. I mean, wasting is bad, but at least if we have already produced waste, we can make compost. I can see tons of compost we can make out of this. You can also see a lot of biogas you can produce from this. There's something wrong about the whole concept. It shouldn't be in a landfill like this. So what seems to be the problem? I think we had some interesting talks this morning about linear economy versus circular economy. These are fancy words for some very simple stuff. Now, linear economy. For hundreds of years, we got used to a simple concept of taking anything we want from natural resources. It's right there. I don't know if the clicker, the laser pointer works, so maybe not. All right, take anything from natural resources, we make things, that's about the production, and then we use, and then the rest goes into no, laser pointer. Is this a laser pointer? No. Okay. Thank you. And it becomes waste. We had the opportunity to do this for a long time because we actually thought natural resources are sort of endless, limitless. We can just take it and do whatever we want to do with it. But we were wrong. So about 30, 40 years ago, we realized that no, we have to put part of it back in the system. So we started doing recycling or recovery. These words became very popular, sustainability. So it's actually nice because if you can put part of this material back into the system, like how you see in this arrow, the linear economy all of a sudden becomes a circle. It goes in a circle. Or is it? Is it that easy? So after 30 or 40 years of recycling, recovery, talking about sustainability, all this stuff, our economy is still only 9% circular. That's how much we put back in the system. So our economy, that means 91% not circular, still linear. What seems to be the issue? There are two issues. You can see that a lot of waste is still going out of the system, the waste arrow. That means we have to take a lot of material from nature to compensate, to produce new things. Now, so one problem, I said it's related to the waste. We are actually taking a lot of steps now, which is a good thing, but is it enough? I mean, look at this. We know how to recycle paper, but after like 50, 60 years of paper recycling, our numbers are still less than 60%. Organic waste. We all produce organic waste. In developing countries, the numbers can be as high as 65% of the entire waste content. That's organic. We can make compost at least as a minimal, or biogas, or so many other things. But composting industry, I mean, the answer is obvious, but composting industry actually struggles because we don't have a system with the right policies to back a business model for composting. On a global scale, we produce 330 cubic kilometers of wastewater every year. On a global scale, we don't utilize more than 5% after treatment. I mean, it's a lot of water in one place, especially in water-stressed countries. This can be an enormous resource. We don't know how to use that. So we are actually trying to utilize waste and try to recover and recycle. We are not doing enough. This is the other part of the picture. So waste, at least we are talking about it. This conference is mainly about waste management, sustainable waste management. But the real problem is we are not looking at the whole system as one cycle, especially about the production and consumption, or in simple words, make and use steps of the linear economy. Now, some examples. On a global scale, out of our freshwater usage, 70% goes to agriculture. Fresh water, 70% of fresh water we use nowadays, it goes into agriculture. Do we really need drinking quality water to produce crops? The answer is no, but we don't know how to do it in any other way. Well, I think we heard about this before, about the food waste. Again, on a global scale, at least 30%, it can even be 40%. In some countries, it can be like 50%. 50% of food is wasted. And I can assure 1/3 of it actually doesn't even see the table. We just lose it. We just waste it. Cattle industry, I think we all like to eat beef. But the cattle industry consumes 75% of all the agricultural resources to give us food, which is equivalent to only 8% of what we eat. Look at the distribution. 75% of all agricultural resources are in cattle industry for dairy and beef, but we only receive 8% of what we eat. So obviously there is something not right about the whole production and consumption part of the cycle too. Now, I want to bring up a new concept. This is again a fancy name given to a simple concept. The problem with this cyclic thinking is that we haven't adjusted ourselves to think in a different way. We need new thinking. Just talking about waste management, sustainable waste management, and only looking at that piece of the puzzle is not enough. We need a better thinking. Nexus thinking, which became popular about 2-3 years ago, at least I think after 2011, is mainly about 3 very important things that's essential to our living: food, water, and energy. These 3 things are related to each other. And what Nexus thinking says is actually, rather than managing them individually, try to manage them in one setting, all 3 together, because something from one sector can feed into the other one. It can be also a good place to think about waste, because waste can fed into all 3 sectors. Now, it might be confusing. I already started talking about circular economy. I jumped into nexus thinking as an example. This is what I do with my students. It might work with you too, so let me try anyways. 2015, there was a movie called The Martian. How many of you have seen it? Any hands? It became very popular as a science fiction. I'm an engineer, so I like that kind of stuff, but I like this movie for another reason. This is the best example I can find to teach anyone about circular economy as well as nexus thinking. So we don't have time to watch the movie. In very brief, what happens is Mark Watney was left alone on Mars accidentally, so now he has to figure out a way to survive for 1 year, maybe a little more than 1 year, until there is a rescue mission. He doesn't have enough food, so this is what he does. He grows potatoes using human waste. And for irrigation, he needs to produce water because he has little water for drinking purposes. That's not enough. So he burns hydrogen to produce water. Look at this simple system. The whole planet has one person. There's only one crop. There's only one source of water. But they are all related to each other. And waste plays a central role in all of them. It is one of the best and powerful examples to explain circular economy as well as the powerfulness of the nexus thinking. Now, you might be thinking, okay, well, I'm out of the line. Maybe it's science fiction. No. It actually kind of happens on Earth too. One of my favorite examples about all these new thinking, circular economy or nexus thinking, whatever, Singapore. Singapore is an island. You all know that. That means they don't have water. They have an agreement with Malaysia, which will expire in a couple of years. And they already started working on different ideas back in 1974, long time ago. Nothing happens overnight. Now, they treat wastewater in a very special way, as good as how it happens in a spaceship. You know there's a water reclaimer in a spaceship, right? That's how they recycle water. And this water actually exceeds the WHO standards for drinking quality. So it actually can happen here too. Now, it doesn't have to be as fancy or as technologically advanced as Singapore. This is an example that I wrote about in one of my papers and books. A small town in Colombia, Bogota, I visited this place too. They decided to do something differently more than 10 years ago, about 2005. I think they started changing the whole thinking, and they educated the whole population within the municipality to go for a self-sustainable composting program. They changed policies. They rewrote the policies within the municipality. They found a business model, and now it's functioning smoothly. Now, why am I talking about it? Composting is happening everywhere in the world. No. We do try to do composting, but as a business model, most places actually have failed. This, on the other hand, finally became one of the top 5 model cities. It was ranked by UNEP, United Nations Environmental Program, in 2017 as one of the model cities. It's a very encouraging example. And again, about the policy. Like in Singapore, it happened in a national level. This is only a municipality level. Now, it doesn't even have to be a policy related or national level or a state level or a municipality level. This example, I usually talk about it in talks for a number of reasons. Again, very briefly, this is a real story from Malawi. It happened about 14 years ago. Due to deforestation, a couple of villagers didn't know what to do with agriculture. They didn't have water. They had deep wells. They didn't know how to take the water from the deep well. No energy, nothing, no other resources. Now, this boy saved the whole village by providing irrigation water. How? You see a windmill. You see something like a windmill, right? And you must be wondering why there is a bicycle right on the top of a windmill. Because it's a homemade version of a windmill. This boy basically used his dad's bicycle, which has a dynamo. So the dynamo can produce electricity to recharge an old battery to run a small pump, which is also recycled. And then they got the whole system to work. Food, water, energy, all 3 were related, and he was able to save. And this energy source is actually renewable. It's just wind. There's no cost. So actually, he was saving more waste by not using the other type of energies. Now, next question is, these ideas, they don't necessarily have to be very big. If you want to contribute to circular economy, you just need to be innovative. You don't have to even look for the blessings of the policymakers if you have a bright idea, because the policy can actually follow later if you have one of the best ideas. I have a few examples I picked up from my travel. The first one on the left. I mean, this is nothing unusual, but I found this place in Germany. It's like McDonald's, but look at this little cup on the left-hand corner. When you go to McDonald's, you get ketchup in a plastic cup or a paper cup, right? It becomes waste. It's a smart idea. It's an edible cup. Just eat it. Eat the cup. Even if you don't want to eat it, fine. Put it in the trash because it's degradable. It is food. A little. It saves. We don't have to manage waste if you're not producing waste, right? So there are some smart ways to do. It's simply about tweaking the system you have. Look at this boarding pass. One of my own boarding passes from 2014. I traveled from Dresden, Germany to Colombo, Sri Lanka, like 10,000 kilometers. They printed all 3 boarding passes in one piece of paper. I mean, this is not a big deal, but think about the number of sheets that we can eliminate printing. It's about ink, it's about paper. There are some simple ideas that can go a long way. There you go. I told you these examples are mainly my observations from my travel. And you all know about what these 2 symbols, these logos mean. One is Uber, the other one is Airbnb. Why am I bringing it up? In circular economy, we are actually trying to utilize the limited amount of resources we have, right? So these 2 concepts actually revolutionize the world by encouraging people to rent out their extra space, basically a car or your house. You're renting out extra space, so you probably don't have to make more cars to make taxis, or you don't have to make more rooms in hotels. It's a very unorthodox idea, but it sort of revolutionized because the policymakers actually had to rewrite the rules to accommodate these business models. One of my favorite examples, this is from Schiphol International Airport, Amsterdam. What is so different about this airport? You know this company from Netherlands, Philips, they used to sell light bulbs. I think they still do, but they are changing their business model. Rather than selling bulbs, they are now selling light. So the idea is the company will enter into a contract, like if, let's talk about Qazim University, they will enter into an agreement with an organization, and they will say, for the same price that what you're paying now, we will take care of everything. You don't have to worry. We will give the electricity. We will replace bulbs. We will take care of the entire system. We sell light. What is the secret behind this? Because they can improve the efficiency. It's the same cost to the customer, but the company actually can. You can see this curve. There is a drop in the energy usage twice. The first time when they do it, because they are taking care of the whole system, they actually optimize the cost. And then when they collect data, they know what places should be illuminated at what level. With that data, they can optimize it for the second time too. So the energy consumption has gone down drastically. These are all nice ideas, very much unorthodox, but some of these ideas have already changed the world, because when it comes to circular economy, people are afraid of companies losing money, because if companies are not on board, we can actually take any steps about sustainability. We have to invite everybody, including all these people involved in the production too. Now, with that point, I want to bring you to this. I work for the United Nations, so these things are very much important to me. And I was so proud to hear about the Sustainable Development Goals in a couple of talks this morning too. What I said before was about bringing everybody onto the table. We have to understand each other. We have to tell people in a way they can understand that these changes are real, these challenges are real, we have to do something about it. So Sustainable Development Goals are to be achieved by 2030, and there is an opportunity here because a couple of the goals are directly related to waste and circular economy. Well, you actually heard these SNR colors are from a couple of these goals, if I heard it right this morning. Now, goal number 6 is directly about waste and water management. Goal number 12 is directly about circular economy. And there are other goals that we can contribute by doing proper sustainable waste management. For an example, sustainable cities and communities, number 11. And number 2, no hunger to a certain extent, and climate action, number 13, and a few other goals too. It's an opportunity.
1 minute, Professor.
Yeah, sure. This is actually the last one before last, okay. It's an opportunity to educate people. At the same time, the sustainable waste management can benefit from this knowledge sharing too. All right, this is my conclusion. My conclusion is actually identical to my title. When the economy is circular, sustainable waste management can actually lead to preserving the sustainability of natural resources. You can see this cycle, you have to make it thicker in the amount of what we put back in the production cycle. Waste has to shrink. What we take from natural resources will be automatically shrinking too. All right, that's all. Thank you very much.
Thank you, Professor. Very informative lecture and information. I appreciate it. I will leave the question and discussion after we finish all the, okay. With second speaker we have here with us is Professor Muhammad Ali. He's a professor of mechanical engineering department at the King Saud University. He received his PhD from Colorado University at Boulder. He has a long history of contribution in terms of academic and educational areas. I will leave him to maybe the title. I don't have the title of his presentation or paper, but rather I think it reflects some of his innovation and invention. He has got some patent on it.
Thank you, Mr. Chairman. Today I'm going to talk to you about the new thermal insulating material extracted from what we can consider them as wasted material. Okay, so one of them is extracted from apple of sodom trees, and the other is the surface fiber extracted from the palm trees surface fiber. As we know, insulating material is very important for our daily life. It is necessarily for building and for refrigerators and for a lot of things, especially in Saudi Arabia, since we are using air conditioning and our building wall has to be insulated. And here we are looking for natural insulating material instead of using synthetic ones, which usually used binder contain formaldehyde, where the formaldehyde is hazardous to human beings. So the first one is I'm going to extract from Calotropis borosera, or apple of sodom. In Arabic they call it al-ushar, or sometimes they call it شجرة الشر أو الشيطان, whatever. Okay. Why you are using this? Because it is eco-friendly, insulating material. It has no hazard to the human being. When I bind the fiber, I use the cornstarch as a binder, so everything is natural. It has a very low thermal conductivity. It doesn't absorb water because its fiber is very silky like hair. It is spread all over. It has a lot of it in Khorma with Taif. Okay, there is a lot of in a forest form. This is how it looks like. Okay, usually between up to 5 meters. Its root it goes down. Okay, even if the authority come and cut it because it's absorbed a lot of water, within 6 months, since its root is down there, it grows up again, and we can get the fiber. So the fruit, it's like the mango, it's here, and when in its mature time, we see that the brown is a brown seed hugging the fiber inside. When it's mature time, when it's open up, this white fiber is the fiber which I'm interested in. This is how its fruit, the flower looks like. And the final one is the white fiber is the one I'm interested in. The second fiber is the surface fiber extracted from the palm trees fibers. Okay, this is how it looks like. Okay, so these are the two fiber I'm using. So I use this as a single fiber, making some specimen and measure thermal conductivity, and for the same for this one. And then we modified it by making hybrid between both of them. Since, as we will see, the fiber extracted from the apple of sodom fiber, it has a very low thermal conductivity, even better than the palm tree surface fiber. So but the palm tree surface fiber has more strength. So when we make a combination hybrid between them, we get a new specimen with new characteristic of thermal conductivity, new characteristic for sound absorption coefficient. It has a high sound absorption coefficient, as we'll see. Okay, these are the 4 samples I have made with this characteristic. Okay, as we see, the first one is pure palm tree surface fiber. Number 1, it has 7% apple of sodium fiber. Number 3, it has 17%, and the rest is the cornstarch binder and the surface palm tree fiber. And number 4, so it's different ratios. Number 5, it has 58% palm tree surface fiber and 34% palm tree surface fiber. Okay, so these are the 4 samples we have made, compressed, used cornstarch as a binder. Thermal conductivity test is tested for all of them, from 10 degrees centigrade up to 100 degrees centigrade. These are the matrix of the all samples I have used. As I said, there are 6 samples. One of them is single apple of sodium fiber, and the other single palm tree surface fiber, and the other 4 are a hybrid between them. And we have 3 samples. We used, one of them is glue. We used a glue as a binder just to compare for, with the other one is the white cement, used to compare this with the cornstarch binder for almost the same density samples. Here, as you see, this is the thermal conductivity profile for the 4 samples. Start from 1 is a pure surface, palm tree surface fiber. And as we see, when we increased the apple of sodium fiber inside in hybrid sample, we see we got a good thermal conductivity, which is lower thermal conductivity. It's a good characteristic. And also we see the apple of sodium, the standard for insulating material. Okay, American Society Mechanical standard. And here the R value, or the thermal resistance. This figure shows a comparison when you use different binders. As we see, when you use the glue binder and cornstarch and the white cement binder, so the best of them is the glue binder. Since if you do the thermal conductivity for each kind of this binder, you will find the cornstarch has a higher thermal conductivity. That's why when you use it for binding the fiber, you will get the best one is the glue binder. This glue binder is the one used for wood, to glue the wood, the white paste. Okay? And this is the corresponding R resistance, R value. We also did the sound absorption coefficient to measure the sound absorption coefficient for the specimen to check that if it does absorb the sound in addition to has a lower thermal conductivity, and it does. Okay, all of them, as we see, we did for sound absorption coefficient. Just to remind you, if the sound absorption coefficient is 1, it means completely absorbing the sound. If 0, it means there is no absorption at all. So this, it means that we about 50%. This is another sample. It has a 50%, so it means it's good, okay, as a sound absorption coefficient. Here's to show you the microstructure, the diameter of the surface fiber between 5.5 micrometer to 20. And here it shows the thermal stability of the apple of sodium fiber. It's stable up to about 200 degrees centigrade. it loses 50% of its weight at about 330. So it's a good. It can be used as a candidate for the thermal conductivity for building. It shows the degradation of the fiber, apple of sodium. This is the, it shows the diameter of the fiber. It's very fine and very thin, about 13.5 micrometer. This is the thermal degradation, thermal stability for the palm tree surface fiber. It's stable up to 232. So both of them can be used as a candidate for thermal conductivity material. It can be used in building, either between the two walls. So the conclusion, the hybrid specimen of biodegradable, eco-friendly, green, wasted material can be used as a thermal conductivity for building. It has very low thermal conductivity. The average of the thermal conductivity between 0.0418 to 0.056 watt per meter Kelvin, which is in the range of the natural insulating material, which is between up to 0.07. So they are good. So when you include the surface fiber as a hybrid with the apple of sodium fiber, it gives more strength. We have done a lot of experiment on that, but I'm just in 10 minutes I'm presenting this. But for more details, there is 4 publications in here. One of them is in a Q1 in construction and building material. So it's characterized as a Q1 in ISI. So for more details, you can find either about the palm tree surface fiber or about the hybrid between palm tree surface fiber and apple of sodium fiber and agave fiber, but there is no time here to show everything. And thank you for your attention.
Thank you, Professor. Yeah, good time. Well, we use your material. We used your material.
Yeah, I'm going to leave this.
No. Yeah, we built our student last year. We participated in an international competition about, it was solar decathlon. Solar decathlon 2018. And our team participated in the house. We built it in Riyadh and then we transferred it to Dubai and brought it back. Now it's in the final stage of just rehabilitation. But we use the material of Professor Muhammad for insulating the walls of the house. It's worked very well.
It worked very well.
Yeah. Thank you, Professor.
It has a very low thermal conductivity.
Thank you, Professor. Okay. The third speaker we have with us, Dr. Qadir Ahmed, is Associate Professor of Water and Environmental Engineering at Faculty of Engineering, Islamic University in Medina. As I mentioned, this is specialized in water and environmental engineering. Doctor?
Bismillah ar-Rahman ar-Rahim. Thank you, Mr. Chairman. My paper talking about the study for environmental and financial analysis for waste management option in Medina. Case study applied in Medina Solid Waste. My presentation have introduction and study aims and then the methodology and some result and discussions. First of all, regarding the background, from the morning we listen for a lot of background about the solid waste and how the problem is alarming and how this problem is how we have a huge amount of accumulated waste everywhere. It's not only in one place. There are several methods also have been investigated to cope with the waste generation, how to deal with the waste generation, how to manage what we call management option for different options we can follow to reduce or to prevent or minimize the waste problem. That's the general rule which we, as you can see from the figure, reduce at the top. All colleagues before said that's the reduce or prevention, how to prevent or minimize the amount of solid waste will be generated, and then after that will be reused and recycled. how to can, again, to reuse these materials, so you will save some raw material and resources, natural resources, because you reuse, again, the same material. And at the end, we can say that the bad option or worst option, it is disposable the waste, which we said we accumulate a lot of tons of waste will be landfill and the ground. So accordingly, for the process of waste management, all the process of waste management or waste management option should be start with how to collect and how to transport the waste, how to collect the waste from the household or from the place of generation, and then how to transport. And the first step for any type of waste management. The other part, which my concern in the paper, regarding the payment, relationship of the service payment between the customer and the service supplier, or we can say are indirect, because maybe the customer doesn't recognize the service that they received due to the service is mostly undervalued or underprovided. So a lot of money is spent to collect the solid waste. And the majority of people not concerned about that, and they still, as we said before, generating a lot of waste. So accordingly, if you look for the value or the money back of the waste, if I try to use or reuse or recycle, whatever the option I will be, by applying some advanced treatment to the solid waste, the first look we can say it's generally cost a lot of money to do any advanced treatment for the solid waste. So my paper focus on what the money back we can get it from the for managing the waste by different type of what we can call advanced treatment. So my studies focus, we focus my study on the Medina region as a case study, because we can say it is one of the largest cities in the kingdom. The study, as we said, two parts. One of them, it will make analysis for what the quantity of the solid we generated, what the type of the solid waste, and so on. And then the other part, looking for what the significance of the financial aspect of the waste generation and different waste management method applied, or maybe we can in future we can apply. So the study area, as we said, it will be in Medina City. Some brief idea about the Medina City. We have like seven, the Medinas can be divided for a 7 region or 7 sectors. Also, that's some information about the Medina, like the total area is 151,000 kilometers square. What we have here in Medina, we have this figure showing, sorry, this one, showing the 7 sectors, which each sector it will be responsible about collecting the waste from this area. So starting with the result, the first part, as we said, from the work is just we make analysis for what we collect from information regarding, first of all, that's the waste generation from different sectors, 7 sectors, starting from 2007 up to 2016. As you can see, regularly there are increases will happen with generating the waste. And we got like a jumping in 2015. But in fact, when we're looking for the type of waste, it was the majority is just a demolition from construction site. That the reason why is increased. A lot of construction activity was in 2015. So for that reason, there are a jump in the value of the waste collected. The other graph or figure showing the collection source, because there are different collectors in Medina. Some of them is private sector or commercial companies. Some of them it related for the Medina municipality. As you can see, that's both of them collect, and the total shown in the gray line. Let's show the total. In this figure, we show the real correction data and trend equation. That I use some simple equation just to expect or predict how much the waste it will be in the future. So our study or record from 2007 up to 2016. So I try to say what about 2030. How much, accordingly, I have two different trend of equation. One, it will follow the 2015, as we said, 2015 have a jumping in the value of the waste, amount of the waste is collected. So if you follow 2015, it will show a high trend for collecting the waste will be in the future. If you follow the normal, if you just escape 2015 or remove it from the calculation, so we say, so we have two colors here. It is without 2015, the orange color here, and the blue color with 2015. So the big difference is shown here. Okay. The waste composition also here very quickly, you can see from construction waste, household waste, agriculture. So the majority coming from household waste, the majority of the waste in the Medina region. And then in this graph, we show the composition of the waste collected by the commercial company. In this other part, so the first part was just analysis for what we have from the different type and amount of waste in Medina. In this graph, it is just estimation for the cost. When we cost for different element, we follow some standard studies for estimation the value or a cost for each type of or each element for the collection system, like small bin, medium bin, large vehicles. We use small vehicle, large vehicles, and so on. Worker, like supervisor and normal worker working with this field. We have these numbers from the authority in Medina. Approximately it was in 2016. And based on some standard value for cost, some of them is local from here, Kingdom, and some of them is worldwide cost standard. We estimate how much 1 ton will be. It is approximately around 67 real just to collect 1 ton of the waste here in Saudi Arabia. It may be more than, because some numbers shown early here talk about total amount of money spent in a year may give you more than this average. But this average, it is estimated, we can say accurately according to the real number in Medina, and we can add like maybe 10% for administration and so on, that the total. So based on this value, 67 ton for each, 67 real for each ton, we can also look for the some types of management option like recycling. If I do recycling for different elements of recycling like paper, plastic, glass, or metals, according to the quantity we have and the price, we can say that's orange color showing the money back. The money back of the recycling, how it is spent, and how it's showing, in fact, there are a little some benefit, but it show at least if I do recycling for this element, I can return my money which I spend to collect the solid waste from homes and so on. And also in this other type here, we compare by different scenario. If I do a landfill for all my waste, I don't have any money back. It's just to spend money. If I do recycle, landfill or recycling, and that's based on 50-50%, or it's based, in fact, on how much I can recycle in my waste. So accordingly, I can say the money back will be less. It is less, but at least I got like more than 50% from I spend, I get it back again. Also for landfill was compositing, which we can generate methane gas and so on. Also this is showing I can get some benefit and some wins from the, so at least I can say all my money is back now for recycling and compositing together, and no landfill at all. There are a big money back now here If I completely do any landfill, I can do that. Sorry, Chairman, just very quickly.
-1.
The conclusion, yes, conclusion.
-2.
We already said what we said in conclusion regarding the best scenario. As we said, it will be compositing and recycling. Thank you very much.
Thank you, Doctor. Now we moved to Dr. Muhammad Sharik. Dr. Muhammad Sharik is an assistant professor at the Department of Civil Engineering, Alger Muslim University in India, AMU. His specialty is structural engineering, correct? Yeah. He has many publications, some of the structural aspects and even construction and building materials.
We can use this one.
Dr. Muhammad, please, go ahead.
Assalamu alaikum. My presentation is on age-dependent mechanical properties of recycled aggregate concrete containing industrial waste, a clean and sustainable solution. In concrete industries, sustainable solution may be in twofold. One is consumption of cement, that is ordinary Portland cement in concrete, and the second is use of natural resources such as fine aggregate and coarse aggregate. Now in the present research work, I have targeted natural resource materials, both fine aggregate and coarse aggregate, because in concrete, these two materials covering maximum volume. That's why I have considered this. So during my presentation, I will also discuss the critical issues related to the use of recycled aggregate in concrete. That may be the research gap and may be considered for future study. If we are able to resolve these issues, then that will be the biggest contribution in the sustainable development through concrete industries. The experiments in the present study have been conducted by two undergraduate students, Mr. Ashraf Saxena and Mr. Saroj Suleiman, under their BTech final year project under my supervision. Now if we observe the structure like concrete bridges, dams, concrete tall buildings and rigid pavements, huge volume of concrete is required. Now in the literature it is given as 25 billion tons of concrete are used annually in civil engineering construction, and out of these 25 billion tons, 18 to 19 billion tons are the natural resources required for the civil engineering construction. So huge amount of natural resources material such as fine and coarse aggregates are required. The reduction in the consumption of natural resource material in concrete construction is an urgent demand for environmental protection and disposal issues also. Worldwide, millions of demolition waste and industrial waste are generated every year. So this waste is going into the landfill, and maximum percentage is facing the disposal problem. Now, recycled aggregate and industrial waste can be used in concrete construction, but proper guidelines are needed, and amendments in the mixed design code and design codes is also required. So overall, if we are using the industrial waste and this recycled aggregate in concrete, then it may be the economical construction in terms of natural and industrial resource conservation. Now, I have also gone through the past studies. In most of the studies, I have found further research is recommended regarding the preparation of the recycled aggregate and some mechanical and durability properties of the recycled aggregate. Finally, I came to know that past studies revealed that the conclusions drawn from the experimental studies are limited and ambiguous and not sufficient to recommend the use of recycled aggregate in concrete construction. Therefore, further experimental investigation is needed on the age-dependent mechanical properties of concrete containing industrial waste and such as bottom ash and recycled aggregate. Now the common material that we have used, cement, fine aggregate, coarse aggregate, naturally as well as manually prepared. Water is potable water we have used. Now bottom ash we have collected from the National Thermal Power Plant, Dadri, Uttar Pradesh, India, which is one of the biggest electricity generation plant using coal, and basically it is a coal bottom ash we have used as a industrial waste. Now recycled aggregate we have prepared from the demolished concrete building. It was demolished after 27 years of its construction. Then we have collected the concrete boulders, and recycled aggregate we have prepared in the laboratory with the help of some hammer and other tools also. Now these are the mixed proportions prepared with the help of industrial waste and recycled aggregates. We have used 50% industrial waste and 50% aggregate, recycled aggregate in one mix. Then in another mix, 100% recycled aggregate and 100% industrial waste in other mix. Now, for preparing this table, that is some amendments is required in the mix design of the concrete. So we have prepared 100 by 200 mm cylindrical specimen for 28 days and 90 days curing. We have used the submerged condition. Then there may be another issue related to the procedure of the curing, that may be membrane curing or accelerated curing we may use. So further research may be recommended in all aspects related to the preparation of the recycled aggregate or industrial waste concrete. Design mix procedure is required. If we are able to give the design codes related to the mixed design of recycled aggregate, then this will be the another big contribution in the concrete construction. Now we have tested the cylindrical specimen under compression for knowing the compressive strength of the concrete and splitting tensile strength of the concrete. Through compressive strength of the concrete, we have also measured the modulus of elasticity of concrete. These three mechanical properties are directly related to the design of concrete structures, and designers cannot ignore this property of the concrete. Now on the results and discussion part, if we observe the strength at 28 days with the help of 50% and 100% recycled aggregate and industrial waste like bottom ash, we are observing 70% and 61% strength respectively of their as compared to the plain concrete strength. Whereas at the age of 90 days, it increases as 74% and 65% respectively. So if we compare the strength contribution, then if suppose on some project M25 grade of concrete is recommended for the construction, then if we are using the industrial waste and recycled aggregate waste, then we should enhance the grade of concrete, say M30 or M35, for achieving the design strength that will be recommended for the design of concrete structure. Now, rate of gain of strength, we have also observed by using 50% and 100% replacement is 14% and 16% respectively. Now, among all recycled aggregate concrete mix and bottom ash concrete mixes, 50% aggregate replacement has been observed as the optimum concrete mix. Now, likewise, splitting tensile strength we have also measured, and modulus of elasticity of concrete is also measured. In all the way, we are observing decreasing trend of the strength development as compared to the plain concrete strength, because proper methodology for the preparation of recycled aggregate is need of the day, and it means that strong aggregate cannot give the strong concrete. But for a strong concrete, strong aggregate is essential. So it means that strength is depending upon the strength of the paste we are using in the concrete and bond between the paste and the aggregate. So some microstructure analysis is also required for in the future, so that we can observe the behavior of the failure in the recycled aggregate concrete. Now we have also tried to develop some empirical relations between the cylindrical compressive strength and splitting tensile strength, and cylindrical compressive strength and modulus of elasticity of concrete, these relations can directly be, can be
Doctor,
helpful for the designers
we are
so
passing the
that
10
he
minutes.
can use for fixing the preliminary dimensions. So we came on the conclusion part, one or two conclusions which are, this aspect we have already discussed, the strength is lesser than the plain concrete strength, but the experimental data and proposed empirical relation will be helpful in the design of concrete structures made with recycled aggregate and bottom mesh, and also contributes to sustainable development. Designers can use these empirical relations for fixing the preliminary dimensions of reinforced and pre-stressed concrete members made with recycled and bottom mesh concrete. So analysis will also helpful to reduce the experimental time, so that, and designers can directly use these relationships. Further studies are required to develop the more rigorous empirical relations for recycled aggregate concrete. Okay, thank you.
Thank you, Doctor. Yeah, Dr. Ghulam is an assistant professor in industrial engineering program at the Faculty of Engineering and Applied Science, University of Regina, Canada. Okay, Doctor, please, go ahead.
Assalamu alaikum everyone and good afternoon. So I'm Dr. Ghulam Kabir, and the title of my presentation is the Economic Efficiency Evaluation of Canadian Solid Waste Management System. And the co-author of this paper is Dr. Kelvin. So both of us are working in the University of Regina in Canada. So from the title you can assume that in this paper we try to evaluate the economic efficiency of different Canadian solid waste management system. So what is the objective of our study? That as we already discussed from the morning, that the sustainable and the integrated solid waste management has become a critical issue because of the rapid urbanization and the rapid growth of the population, and that's why basically we are in here to discuss these challenges. So now, if we think from the Canadian perspective, then Canada is a developed country, and its solid waste management is also working. But as Dr. Hiroshan mentioned in his presentation, that some of the countries, they produce almost 30 to 40% of the solid waste. Unfortunately, Canada is one of them. So on an average, Canadians produce almost one of the highest per capita solid waste generation rate. So now if you think that why, as a developed country, what is the challenges in this case? So from this map of the Canada, we can see that the Canada is a very large country with an area almost 10 million kilometers square, but with a relatively lower population, around 37 million. So how big and how small? So if we compare with the Saudi Arabia, then the population of the Canada is only 3 million more than the Saudi Arabia. But if we compare the area, then the Canada is almost 5 times bigger than the Saudi Arabia. Okay? So then from this comparison, we can assume that land is not a problem. How to manage that is the main issue. Okay? So that's why the landfill is the most common solid waste management system, the technology in Canada. And another issue, if you see that the Ontario, which is the Toronto is the popular city of the Ontario, and the Quebec, Montreal is the popular city of the Quebec. So if you only consider Ontario and the Quebec, then almost 65% of the total population of the Canada state is only these 2 provinces. And rest of the 8 provinces and 3 territories, only 35% people are staying there. Okay? So from here we can also assume that there is a huge difference between the population and between the size of the municipalities. Okay? So that's why this became a challenge if we compare the overall scenario, then it looks like it's not that much good. So that's, and as the landfill is the main technology, so it also increases the greenhouse gas emission. And to measure the performance of different solid waste management systems, the waste diversion rate is mostly commonly used, but it cannot fully encompass the efficiency of the solid waste management system. And also in last year, Canada made an agreement with the UN that Canada will ban the single-use plastic as early as by 2021. Now the federal government did that one. So now the provincial government or the municipality had to find out that how they can reach those goals. Okay? So if you have to reach those goals, you have to first find out what is your current performance and who is working better there, and then you can take your strategies to improve your overall system. Okay? So that is the objective of our studies, to assess the performance of the non-hazardous waste diversion system using different economical parameters. So this is the overall summary of our methodology, that at the beginning we find out that what are the indicators which will indicate the economic efficiency based on the literature and also from the discussing with the utility people. Then we collected the data, and then we find out the weight of those indicators using entropy coefficient method, and then we compare the performance of the different provinces using the TOPSIS method. Okay? And I will also discuss a little bit about those in the beginning. So in the first stage on the methodology part, so we consider only 4 parameters in this case. So the diversion GDP ratio, diversion expenditure ratio, current expenditure per ton handle, and the North American Industrial Classification System, where the sector 562 indicate the waste management and the remediation service. So that per ton handle. So why only 4? Because these, we use the open source data from the Statistics Canada and the other report, and we need the data from all the provinces. So that's why we choose only the important criteria and also the based on the data availability. But our framework can consider more criteria for the analysis. Then we use the entropy coefficient method to find out the weight or the importance of the different indicator. Okay? So as we are comparing different provinces, so the expert can be from different provinces and they can be biased, and that's why we only use the objective weight coefficient method, that the weight of the criteria will be determined based on the data, so we don't need any expert judgment to determine the weight in these cases. But the issue of this method, that it cannot consider which criteria is beneficial and which criteria is the cost. So that's why, to remove that limitation, so we rank the different provinces using the TOPSIS method. Okay? And the TOPSIS method will help us to find out which province is close to the best ideal and far from the negative ideal in this case. And then we try to apply this framework to find out the performance of the waste management system of 5 provinces. So from British Columbia, BC, then Alberta, Saskatchewan, Manitoba, and Ontario. So why only 5? So there are mainly 2 reasons. So the major reason that Ontario is considered the east of the Canada, and British Columbia is considered the west of the Canada. So basically these 5 indicating from the east to the west side. Okay? And another minor reason that I stay in the Saskatchewan, in the blue, which is in the middle. So I take 2 from my right and 2 from my left. Okay? So that is another reason. So then we find out the data of different provinces, and for those 4 criteria, what is their performance based on the report published in 2018, and we use the 2012 data as a benchmark. Okay? So this is the summary of the performance of 5 provinces with respect to the 4 criteria. And then we use this data to find out which criteria has higher importance. And this chart is indicating that based on our analysis, it is finding out that the diversion expenditure ratio has the highest importance. And using this weight and using this data, we use the TOPSIS method to rank to find out the performance of different municipalities. And this is the performance of different provinces. So in here we can see that the BC, which is the west part of the Canada, their performance is good. And Ontario, which is the east side of the Canada, their performance is good. but in between the other three, their performance is not that much satisfactory. So for the discussion, so as I already mentioned that the BC is performing well, and Manitoba and Saskatchewan, they are far behind in the performance. So the other four can follow the strategy of the BC, that what they are doing, why their performance is good, what are the strategies they have to take for the short term and the long term cases. Okay. So this can be the implementation part, and on the federal part, they know that the performance of the BC is good, so they can fix the incentive for them, and they know that the performance of the Manitoba and the Saskatchewan is not good, then they can find out what can they provide the subsidy to improve their performance in these cases. So in conclusion, so in this case, we try to find out the performance of the 5 Canadian provinces using the economic criteria, and the utility manager can take a strategic decision, and they can find out their benchmark and how they can also improve their performance. And from the limitation point of view, and in here we only consider the economic criteria, but if we have to consider the overall picture, like there can be criteria from the operational point of view, environmental point of view, so we can also consider that one. Okay. And also from the methodological point of view, so in this case we use the entropy-based method, which totally depends on the data. So now we can also use the judgment of the expert, and we can also combine that one with the objective-based method, and that will give us a more better result, whatever we are in here. So currently we are also working in the improvement of this paper, and that is it for my side. Thank you, everyone.
Dr. Osama Arfan is Associate Professor of Mechanical Engineering at the University of القصيم. I think he will be talking about scrub rubber recycling.
بسم الله الرحمن الرحيم. السلام عليكم. I know that we are at the extra time. I have been given 5 minutes to finish. So I will try, inshallah, to do it simple and short. Our paper is a review paper about the impact of scrap rubber recycling on sustainable development and environmental improvement. The layout of the paper, something about the introduction. We will talk about the rubber tires, its components, its effect on the environment, recycling and using of each part or each component of the rubber. The paper generally focus on only one kind of waste of the scrap rubber. Rubber itself is a disposable material. It's difficult to dispose, and it should be used in other industries. And this review paper emphasizes on these industries. As mentioned before in other papers, the management of waste is divided into many kinds: reduce, reuse, and recycling. This is the composition of the rubber tire. Mainly, it consists of vulcanized rubber with steel for reinforcement, and carbon black as an additive to reinforce and enhance the wear resistance and the stress of the material, and the other chemicals. This industry, tire industry, is growing very rapid, and as mentioned here, or as shown here, this is the composition of each component of rubber. This graph shows the produced rubber all over the world, divided into regions, and it's shown that the China has the highest production, while Middle East and Africa has the lowest. these are the major components of recycling tires or scrap tires: shreds, chips, granules, fine powder, steel fraction, and textile. All these types has its technology to produce and has its applications. And the environmental impact of rubber, it's conflicting with always with the cost and quality of the products. This triangle is the most important thing. That recycling means that we want to use it, but the problem is the economy. And even if we overcome the problem of economy, we will face the problem of the quality of the product. And sometimes the recycling itself or reusing the material itself may make some emissions, which is also harm for the environment. So this complicated issue should be treated when dealing with the recycling tires. This is a technology of how to recycle. There's many kinds of technologies. Many research have been implemented to produce different products of from recycling tires, and it divided into solid, gas, and liquid. It's according to the condition by which the tire is processed. Application of scrap tires is divided into two many parts. Firstly, using the entire rubber tire, recycled tire, it's used in many applications, and all these applications, mostly engineering applications, and it depends on the property of each of the tire which used for this for these applications. The shred and chips used in another applications, and it depends on the thermal conductivity, and we knew something about thermal conductivity and its applications for the for tires in insulations. Using of granulate tires also used in automotive, in sport surfaces, in some industrial products. The fine powder also used as from the scrap tires in other applications. Using of scrap tires in energy recovery. This is the most important. Energy recovery is the most important application of scrap tires. It is the vital part of tires as a sustainable issue. So using the tires, and mostly it's used as a fuel in the cement industry, as we also as mentioned before in morning. The applications of scrap tires in civil engineering is also very famous. It's used in many applications, and these applications depends on the industry itself. Used in cement, it can be used in some insulations, in boards, as you will see after, inshallah. This is kind of applications of the scrap tires. It's used in asphalts, to be added, and as you see here, it's conventional asphalt to the left and rubber overlaid with asphalt by using some kind of tires. Also, it's used in insulation boards made of recycled tires. So the most important thing when dealing with tires, scrap tires, is to try to use each component of it, to not be forced to landfill it because it is very harmful to the environment. these other industries can be used by scrap tires, sport products, dairy cows mats, and all these kinds of applications can be applied by the from scrap tires. Finally, the paper focused on the application of recycled tires from rubber. Also, the paper did not talk about the other materials like plastics, polymers, wood, paper, and all these kinds of things also needs studies and more studies to use it to use it as a friend materials for the environment, and all these things should be managed through especially recycling and reusing, to use it in a positive way and to be sustainable to the environment. That's all for the presentation.
Shukran.
Thank you very much.
Thank you, Doctor. Thank you very much. Appreciate it. Let's have a seat.
Not minus one.
No, it's very good. I'm just on time. Just on time. So now it's, we have some, maybe 5, maximum 10 minutes, I think. Already now 5 minutes past 4. So I will start with the ladies and the girl side, on the other side of the lake. So ladies and girls, if you have any question, please kindly speak up. 1, 2, 3. No question from that side. Okay. Okay, we'll start from this right side. No question. Middle side, please. You have a microphone.
السلام عليكم ورحمة الله وبركاته. رضوان المصري من جامعة القصيم كلية الهندسة. دكتور محمد، مشان تصنيع المواد العازلة إذا بتريد صار في دراسة للناحية الاقتصادية؟ شكرا.
There are some statistics about that, but the paper working. There are some statistics about this paper by another author, but the number, I cannot remember the number right now, about how many hectares and how many tree can be in each hectare and how many you can get. I think it's about a half ton from 4 hectares. Okay, half a ton of fiber.
The cost, how many cost?
No, we haven't done the cost yet for that.
Okay, thank you.
Okay, well, this side, we'll come back to you. Please. Yeah.
Thank you. I have 2 questions. The first one for the keynote speaker, that we have to be very careful with the energy, water, food nexus. As we were trying to improve the water pumping using solar energy, which is an alternative free energy, the effect on groundwater depletion in India was enormous because the farmers put their hand on this technology and they start using the pumps irrationally. So we have to be very careful when we are promoting energy friendly use and these technologies without any rules or things like this. The second question to Professor Muhammad, since the material is organic actually, what is the possibility of being degraded, or it is resistance to mold growth and the bacteria and these things of contamination? Thank you very much.
Okay, you want me to respond? Is that okay?
Yes, please.
Yeah, okay. It's not a comment, it's a question. Okay, good. Well, you have to put it into the right context. That's what I have to say, because I am taking these examples, everything is relative. Because you're picking on one example about this boy from Malawi, that story, what he prevented was migration of thousands of people out of that village into a city to nowhere. So I'm not saying that these examples can be replicated in many other cultures or countries. No, that's not the point. But I was trying to pick on the importance of these three things and how they are related to each other in our lives. Water is connected to agriculture, it's connected to waste, it's connected to food. So I think if there is anything to learn from that, learn that part and put it into your perspective. I'm not encouraging people to go for groundwater and deplete it as a resource. That's not the point. Thank you.
Mohammed?
Regarding the mold growth for the apple of sodium fiber, when it's dry, it resists the mold growth up to 75%. Okay? When it's wet under the relative humidity, 95%, it's about 50%. But the case is worse for the palm tree surface fiber. It's 50% when it's dry and 75% when it's under the relative humidity, 95%. Okay? So the better is to use it whenever it is a dry places. Okay?
It has to be like as we did in the wall. It's doing very well, by the way. We measure the temperature on outside and inside. It's doing very well. Okay, back to the first one here. Back to this first. Okay, Professor Hussein. Yeah.
أنا عندي اقتراح recommendation based على الأفكار الجميلة جدا التي قدمت هذا اليوم ولخصها الأخ الجناح الشمال هناك left winger في the inverted triangle. أقدم this recommendation to the organizing committee, maybe raised to the vice chancellor, أنه this inverted triangle with reduce, reuse, recycle, dispose should be a motto للجامعة وعشان ما you should not contribute to the waste, it should be painted, not paper. Painted on the walls everywhere, on the cars everywhere.
Dr. Salim, did you hear that?
This triangle,
Dr. Mishal,
reduce, reuse, recycle, dispose. That's a recommendation to the committee.
Okay. We'll mark it down. I will take Dr. Ustaz Ahmed.
سؤالي للبروفيسور محمد بخصوص الانسوليشن. I did not notice a comparison of the efficiency between the proposed insulation materials and the other insulation materials such as rock wools insulation and other insulation materials.
Well, in 10 minutes, I cannot present everything, but I presented two papers published in Construction and Building Material. You will find a comparison between the rock wool, which use the formaldehyde as a binder, okay? In spite of that, the rock wool, it has a lower thermal conductivity than all this stuff, but they are using the formaldehyde as a binder for the fiber, which is hazardous to human being. Okay, but ours, everything is natural. I even insist use the cornstarch solution to bind the fiber, so everything is natural, no hazard to human being at all.
Safety aspects, as our colleague here mentioned, the safety aspects for this wooden materials or something, or fire catching or something. I mean, this is one of the things that, like the other polystyrene insulation materials.
All natural fibers, no exclude anyone, they are available to fire. So you have to be careful about that when you use it, and you have, if you would like to insist, you can use the fire retardant. I mean, like in our mosque, we have a carpet. It is, fire can happen anytime, so you have to be careful not throw on you know, a smoke or a cigarette or anything.
Thank you, Dr.
So all natural fiber are subject to fire.
Maybe one more question here. Yeah, please.
Actually, I have another question to Dr. Professor Muhammad as well. Okay. So when you make these insulating materials from these natural fibers, does the thermal conductivity changes with the compactness of these fibers?
Thermal conductivity, it does depend on the density, okay? As I said, I have many samples and I have a variation with the density. All these can be found in details in my papers published, Okay? But yes, it does the thermal conductivity change with the density.
Okay, thank you. I think that would be, I just back to the ladies and the girls. Is there any question back there? Not you. Dr. Omar, تفضل.
Thank you. Another question for Professor Muhammad. I know the material that comes from palm, it is a very highly combustible material. And people here use it usually to start a fire. So I want your comment about this material, in terms of, if it's, I believe it's not resisting fire, but is there any study, have you find any study, in terms of fire?
As I have said, all natural fiber, in spite of a lot of people are using natural fiber, so all natural fiber, it can be burned, okay? They are not resisting the burn. So if you would like to use it in a space, you have to use the fire retardant, or be careful when you use it in a place so it doesn't touch the fire, like the cotton. Cotton it can be burned anytime, anywhere, everything. So you have to be careful when you carry it from a plate where they grow up to the plate where the textile and all this stuff. Okay?
By the way, we left your material on the site, exposed to everything for 1 year, on the location of our solar house. Honest. And just 2 months ago, I asked them to collect them, but they're doing very well.
Yeah.
Some of our students throw cigarettes. Yeah. No, they were just, we spend night there usually. Honest. But doing very well. Yeah. I mean, so far we have no fire.
Because it has been used between 2 gypsum board as an insulator for, as the doctor said, for a Decathlon solar house. Okay.
At the end, really, I would like to thank Professor Harishan, the keynote speaker, Dr. Muhammad Ali, Dr. Arfan, Dr. Muhammad Shirk, Dr. Abdul Qadir, and Dr. Ghulam Akbar Kabir. Dr. Ghulam Kabir, correct? Yeah, okay. Thank you all. أشكركم جميعا إخوان على. Oh, okay. There is some honoring.
Thank you, Professor, for hosting this session. And I would like to thank all of the respected speakers for their insightful presentations and speaks. So I would like to maybe speak in Arabic or a mix of Arabic and English. So I think we have translators, so I will stick with English. So I would like to give this certificate of appreciation to Professor Walid for hosting this session. Also would like to appreciate Dr. or Professor Muhammad Al-Sayyid. We should give him 2 certificates for all the questions that he answered. Also would like to thank Dr. Abdul Qadir Tawfiq. Also would like to thank Dr. Muhammad Shariq. So Dr. Nur al-Din Hamid. Dr. Ghulam Kabir. Thank you. Also would like to thank our colleague, Dr. Osama Irfan. Okay. Anyone who would like to participate in the group picture or الصورة الجماعية, more than welcome.